This is my completed project with my STM32 board. As you see, I have a clock running. You can reset the clock by hitting the button there. If you hit it anywhere else, it doesn't reset, just when you hit the button. And the purpose of this timer is to run with something like battle ropes. And the problem with battle ropes is if you're trying to time them, your hands are full. So if you have a magnetic battle rope, so a rope with a magnet attached to it, you can drop it into the sensors here. It zeroes out your clock and keeps it at 0. But when you lift it up, it starts the timer going, so you can time how long your set is going. The sensors used for my project are called Hall effect sensors, and what they are is a semiconductor that sends out an active high signal when a magnet is detected inside the field. These ones have an LED built into them, which will help demonstrate that. I set the magnet near one of the sensors, it lights up. The ones on the back are lighting up too when it's facing the other direction. And the LCD used to run my project is the LCD 9341 that's integrated into our STM32 discoveries. It's my first time doing any coding with an LCD screen. It's kind of a learning curve, but pretty happy with the results. So this is what I went through with my battle rope timer. I started with 2 tasks. I had to code a clock, and I had to code a switch with the Hall magnet effect sensors that had the switch on when the magnet was detected and off when the magnet wasn't detected. And then basically once I did those 2 things, I just had to integrate them together to make the switch reset the clock. So the Hall effect sensors I used, this is a description of them I pulled from electronics tutorials. And it says Hall effect sensors consist basically of a thin piece of rectangular semiconductor material such as gallium arsenide, actiniumide, or indium arsenide, passing continuous current through itself. When the device is placed within a magnetic field, the magnetic flux lines exert a force on the semiconductor material which deflects the charge carriers, electrons and holes, to either side of the semiconductor slab. This movement of charge carriers is a result of magnetic force they experience passing through the semiconductor material. As these electrons and holes move sidewards, a potential difference is produced between the 2 sides of the semiconductor material by the buildup of these charge carriers. Then the movement of the electrons through the semiconductor material is affected by a presence of an external magnetic field, which is at right angles to it, and this effect is greater in flat rectangular shaped material. So the directionality of the field with the sensors is why I had to set up multiple sensors. If I just had one, you would have to set the magnet a specific way, but because I set up 4 of them, both facing inwards, you can just drop the magnet anywhere between them to activate the switch. This is my wiring diagram. So I just set the 4 sensors there at the end of the breadboard, had a power supply going at the end, powered all of them, and then they each send out a digital signal. So it's going to send out a 1 when they sense the magnet. I used code to have it set the signal to 1 if any of them were 1, but that being said, you could have just used OR logic gates to achieve the same thing and just sent 1 line over to the STM. I wanted to do a function to meet the requirements of the assignment, otherwise I would have just used a logic gate for that. So the way my code works is it takes the Touch 811 class and the LCD 9341 class that Dr. Rogers put together in his GitHub, and the clock app class takes both of those, initializes the LCD settings, it initializes the touch settings, and then it sets up my clock render cycle. And that's the parent class that the rope sensor clock class takes in, and that runs the clock and then will reset the clock for the switch. So the whole thing works together, and then those are called upon by my main. Because I have everything done through classes, there's really not much going on in my main. My whole main is only about 5 lines of code here, just calling on everything. The only thing that I'm actually doing other than running my classes is I changed this threshold setting And that's because I had initially had it set to 2000, and what the threshold does is it's how long it's taking in a signal before it actually sets that it's received that signal. I was getting a little bit of interference, and that was my way of getting around that. 2000 was way too high, so I lowered it to 10 here, and it works pretty well. And that's my assignment.